In the previous tutorial video, we talked about this particular program here, which would determine whether or not all the numbers in a given array are positive. And as we mentioned before, this is one of the categories of problems that we're trying to solve. So given an array, we want to see if all the elements will actually satisfy a particular property. And just as a summary, what we said in the previous tutorial video, the way to really do this is you need a Boolean variable, let's say all positive, and the initial value should be true. And then also we're going to use conjunction to somehow remember or accumulate the result between iterations. So that's what we said before. And also you want to make sure you understand, in the case of the empty array, in that case, you're going to just get the result true. So which means in the empty array, you simply just cannot find any witness that will actually show the property is actually violated, so that all the numbers cannot be positive, right? So that's something you want to review from the previous tutorial video before you go on with the current one. Okay, so for this particular tutorial, we want to really just try to show you how we can solve the second kind of problem over here, which means rather than trying to say all the numbers must be positive, what about just at least one number is actually positive? As long as there's at least one number that is positive, or at least one element that satisfies the property, we're going to give you true. Otherwise, if all the elements fail to satisfy the property, we're going to give you false. Okay, so this is the second kind of problem we're trying to solve. So both kinds are popular or are common. So you want to make sure you can actually know which technique to use. To solve the second kind of problem, let me give you a mini conclusion first, and then we'll go into details about coding and analysis. Okay, so now it's completely symmetric to how we solve the first kind of problem. So let's say we used to get all positive is a Boolean variable, so now we're going to have another Boolean variable, let's call sum positive. So what about initial value? It used to be just true, but now we're going to get false, which means initially we haven't found anything that is going to be positive initially. And then rather than using conjunction, we're going to use disjunction for the accumulation or remembering of the result between iterations. What about empty array? In the case of the empty array, so the way it is going to work is the same as how we illustrated in the previous tutorial video. The state condition is going to be false right away, which means the sum positive will just keep its initial value false. So that means if the array is simply just empty, we cannot find any witness that's going to prove there's at least one positive number. So that's why it's just going to be false. Okay, it's a very quick preview, just to anticipate what's going to happen for the rest of the tutorial video. Okay, let's now first of all go for coding first, and then we'll go for the analysis. Okay, so now what we will do is we're going to actually copy and paste some code. Okay, let's do that first. Okay, so now why don't we simply, actually, you know what, before I do this, let me just do a quick illustration very quickly. Okay, so now let's have a look at this. We did something very similar as the conceptual illustration. So what we will do is we're going to declare some Boolean variable, let's call at least one positive number, or as we'll do in the programming, we'll say sum positive, right? So it doesn't matter. So now the way we're going to construct truthfulness for this variable over here is by, let's say we consider this particular array, and then you can see there's at least one positive number. For example, it's exactly here. So this can be the very first witness we can find. Okay, so this is a witness. So really try to get really used to the idea about witness. Either it's a witness for violation in the previous tutorial, or it's the witness for satisfaction for this particular video. Okay, so this is a witness that satisfies the property being positive. So now what we'll do is we're simply just going to consider all the elements in the array 0, 1, 2, 3, 4. Of course, you can patternize this using a loop, and also we're going to use disjunction over here to accumulate or remember the result, and then for each one of them we'll simply use the larger than, larger than, larger than, larger than. Okay, so now let's think about how it's going to work. For the first iteration, when we consider -2 larger than 0 is going to be false. And the second one is going to be -7. -7 larger than 0 is going to be false. Okay, so you can see false or false is also going to give us false, right? It has to be at least one of the operands being true that's going to make the disjunction true. Okay, let's look at the third one. The third one, as we said, is going to be the first witness. So now 4 over here, 4 larger than 0 is going to be true, right? So now false or true is going to give us true. Okay, so this is the first time that the accumulation result becomes true. Okay, as soon as the accumulation result becomes true, that means it doesn't matter what the other operand is, right? Similar to the previous tutorial, when we say as soon as the all positive number Boolean variable becomes false, it doesn't matter what the other operand is; it will just stay false. Okay, let's see very quickly. So now for the fourth element at index 3 is going to be 5. So 5 larger than 0 is just going to be true. Okay, so now true and true is just going to be true. Okay, stay the same. So what about the last elements at index 4? It's going to be -1. So this is negative, right? But it's not going to change the result because -1 larger than 0 is, even though it's going to be false, but the accumulation result has stayed as true already. So true or false is just going to be true. Okay, so overall the result is just going to be true. As long as we find one witness that is positive, then we're going to give true no matter what. Okay, again, this is only a conceptual illustration. Now let's see exactly how this can be coded up in Java. Okay, and then we'll do some analysis altogether. The way I want to develop this code is not from scratch. I want to show you how symmetrical it is between the two examples. So what I will do is, can we just click on all positive version 1 that we did previously, right click on that, and then you can say copy. Okay, and then you can right click again and say paste. Okay, so now we want to say rather than all positive, I want to say still version 1, but I would say rather than all positive, I would say some positive. Okay, also version 1. Okay, eventually we're going to see 4 versions for each of the problems. Okay, so now some positive version 1. Okay, so now you can see at to begin with, some positive looks just the same as the previous one, right? But now let me change the array first. Okay, what we want to do is -2, -7. So let me just do that very quickly. -2, -7, and also 4, 5, -1. Okay, 4, 5, -1. Okay, so that's the array we want to do for this particular sum positive program. Okay, and then so now the only thing I would change, there's only a few things I want to change. Okay, first of all, let's rename this particular variable. Let's rename systematically. Just move your mouse over this all positive variable over here. Okay, you can see this highlighted in like an orange color. Right click on that, and then go for refactor, and go for rename. Okay, you can see that one is there. You can see every occurrence of that the use of the variable is now kind of boxed. Okay, so what I would do is I would change that. You can see as soon as I try and change it, all the occurrences are being changed, right? So rather than all positive, I'll say some positive. Okay, and then right click and then enter. Okay, so now you can see it's being renamed systematically. So now the initial value, rather than true, I'm going to say false. Initially, I haven't found any witness saying this positive number. And also, in line number 9, rather than using conjunction, I'm going to use disjunction over here. And then here, all elements in the array are positive. I would say some or at least one. Elements in array is positive. Okay, that's a change, right? So I really want you to see exactly how similar or how symmetrical it is between the some positive and also all positive, right? So now let's execute this program here to make sure at least it works, and then we'll try to go back to the analysis exercise. Okay, so now let's simply, for this particular array over here, is simply just going to be true because this is the witness we can find, right? That'll be the first witness. If you right click on this program here, it's a run as Java application, it will simply say true. Okay, right? True, simply because 4 is going to make the sum positive true the first time, and then it will remain true for the rest of the array. Let's try something that we will expect to return false. Okay, what I can do is, let me just comment this out temporarily. What about I simply say, you just cannot find any witness being positive. Let's say we give it an array that's all negative. -2, -7, -4, -5, and -1. So you can see for this particular array, it's not empty. It is not empty. And you can see there's no such number in there that is positive. So there's no witness to actually show that it is true. So the result is going to be false. Let's double check with that. If I execute the program, it's going to say some, at least one number in the array is positive, will be false. Okay, the program actually works. But now we want to analysis on this behavior, which is a more important exercise for you to do. You really want to make sure you really understand the logic behind solving these two kinds of problems, either all positive or some positive. What you have to face later in the lab exercises or lab tests, or when you actually go to workplace, you may have to solve, the property might be different. Maybe rather than being positive, it could be being even, or it can be being a multiple of some number, right? But the way you solve the problem will be just the same. Okay, the pattern is really important and the logic. Okay, so now let me just change this back to the original array, which we expect to return true. Okay, we'll focus on this for the analysis. Okay, so now let me go to the iPad. Okay, let's do some analysis over here. Since we did a similar exercise previously, I'll try to be a little bit faster. Okay. But, still, I want to be complete. So you can always refer to this video over here if you got doubts. Okay, it's really important to understand the logic. Okay, so now, let me just copy and paste the code, which I forgot. So what I would do is, I'm going to, as usual, copy this fragment of code, which covers only array initialization and the loops. Okay, so now I'm going to paste the code over here. Okay, let me paste it. Okay, so this is the code that we just developed. Okay, so now let's have a look. So you can see that over here, let's just trace line by line very quickly. Line number 1, we simply initialize ns, okay, which is here, and notice that ns.length in this case is simply just going to be maximum index being 4, so that should be 5. Okay, so now let's go to the second line. We have a Boolean variable over here, some positive, and we visualize as a box over here. Initial value is simply just false. Okay, you know what? Let me just use red to say it's false. Okay, and then we're going to run the loop. Okay, let's do it iteration by iteration. Okay, the first iteration, I is simply just going to be 0. Okay, 0 less than 5, the length is just going to be true. So we're going to execute the body of the loop for the first time. So we get some positive is simply reassigned to its current value over here, or the ns at position, in this case, I is simply 0, larger than 0. Okay, ns at position 0 is simply -2. -2 larger than 0 is going to give you false. Okay, so this part over here is simply going to be false. And what's the current value for some positive? Well, it's simply just false. So we got false or false is going to give us false. So that means this value over here is going to be reassigned to false. Okay, and this reassigned value is going to be used in the next iteration, which I will show you. Okay, which we also did the illustration in the previous tutorial video. Okay, it's going to be reassigned to just false. Okay, that's the first iteration. Hopefully that's so far so good. Okay, let's do the second iteration. Okay, of course, NSI larger than 0 for this is simply false. Okay, I forgot to fill it in. Okay, let's do the second iteration. For the second iteration, let's use pink. Okay, and now we're going to, first of all, at the end of the first iteration, increment I from 0 to 1, and 1 less than the length of the array is just going to be true, and then we're going to execute the body of the loop for the second time. Okay, and then, so that means we're going to execute the following. Some positive has to be reassigned to the following expression. The latest value for some positive, and this value over here is exactly what you have from the previous one, which is just going to be false, right? Or also NSI larger than 0. In this case, I is simply just 1. So NS1 larger than 0, what is that? NS1 is simply -7. So minus 7 larger than 0 is simply false. Okay, it's false over here. So what do we have? We got false or false. It would be simply false. So that would be right. So that means we got to reassign this sum positive to be just false. Okay, that's what's being achieved for the second iteration. And of course, this particular value over here is going to be used in the third iteration. Okay, so now again, you really want to see how exactly this Boolean variable is being used for remembering or for accumulating the comparison result between iterations. Okay, let's do the third iteration. For the third iteration, let me use green. For the third iteration, we're going to evaluate this particular. Before the third iteration, of course, I will be incremented from 1 to 2. So 2 less than the length of the array will be true. That means we have to evaluate this particular assignments for the body of the loop for the third time. Okay, so what we have is sum positive will be reassigned to the following expression, the same expression. The only difference is the counter for the loop is actually changing between iterations. So now the latest value for the sum positive is simply just from the previous iteration, right? Which is over here, which is false. So that is going to be used over here, which is false. Disjoint with, and then ns at position I is simply 2. At position 2, larger than 0, nsi in this case is simply 4. 4 larger than 0 is going to give you true. So now you have true or false. For disjunction, as long as one of the operand is true, it's going to be true. So it's going to be true, so that means sum positive is going to be reassigned to true. So that means this is the first time we actually accumulate the results so that the sum positive Boolean variable becomes true. Okay, that's the accumulation. So now what we should do is we should go to fourth iteration, right? We still got 2 numbers to go on, but now you should realize since we are really trying to use the disjunction over here, or you can see from the previous one, we're trying to use disjunction over here to accumulate a result. As soon as you get a result that is going to make the sum positive true, it somehow doesn't quite matter anymore for the rest of the array. But that's okay, since the way we write the loop is going to go all the way until the end of the loop. Let's be complete. Okay, so now before the fourth iteration, we're going to, let me use red here. Before the fourth iteration, we're going to do I++. So you go from 2 to 3. 3 less than the length of the array is just going to be true. So we're going to evaluate this for the fourth time. Okay, let's write it out. So sum positive is reassigned to the same expression. The latest value for the sum positive, in this case, is simply true from the previous iteration, right? So it's conceptually, we are reusing that particular variable result over here from the previous iteration, and this will just be true over here, right? Disjoint with ns at position I, and I in this case is simply just 3. Okay, larger than 0. So ns3 over here is simply 5. 5 larger than 0 will just be true. Okay, I'll put true here. Okay, by the way, in the previous iteration, this will just be true over here, right? Okay, just make sure you fill in the table properly. Okay, so now you can see that over here, this is actually true for the current iteration. So true and true, true or true. At least one of them is actually true. So the overall result will just be true still. You can see that since we already got, let me highlight it to you. As soon as this reassignment actually occurred, that means whenever we're trying to put it as one of the operand together with disjunction, no matter what the right hand side is, no matter what, even though it is true, even if it's false, it's still going to get true. Okay. So now that's the fourth iteration. So we still get the correct result. Now let's do one more. So now once we go to the last iteration, okay, the last iteration, before the last iteration, we're going to execute I++. So now I will go from 3 to 4, and then 4 less than the length of the array is just going to be true. So now what about the result? So let me write it down here. So sum positive, so we are executing this particular body of the loop for the 5th time. So sum positive is simply reassigned to the latest value for that sum positive, which is from the previous iteration over here, right? So we are just reusing it. Oh, sorry, wrong way. We're simply reusing it over here, okay? Some positive, right? It's simply just true. Disjoint with ns I. So what's I in this case? I is simply just 4. ns4 is larger than 0. ns4 in this case is simply just -1. So this particular expression over here is simply just going to be false. Okay, I'll put it here. But now, is it going to make the accumulated result true, false again? Is it going to make it? The answer is no, because you can see the accumulated result is already true, and given that we are talking about disjunction, so true or anything, including false, is just going to make the overall result true. Okay, so now, so that means true or false, it's just going to give you true. So now you're just simply going to rewrite it to just true. Okay, it seems like I missed a minor detail from the illustration. So now I forgot to say from the previous one, from the previous iteration, when we reassigned that to be true, so this should be true. And then for the current iteration, when we reassign that again to be true, this should be true. Okay, just in case you have doubts. Okay, so I just forgot to write it. Okay, so now eventually this is the true result that we're going to return, because at the end of the fifth iteration, so now if you try to say execute this I++ again, so now I will just be incremented from 4 to 5, and 5 less than 5 is just going to be false. So now that means we are done. We exit from the loop. So eventually the result we're going to return is true. There's at least one element in the array that is positive. And to be more precise, you really want to see, as soon as we have some positive calculated to be true, that's really the point that it's actually determining the overall result already. Okay, so but again, you want to see really exactly how we use the disjunction over here in each iteration to accumulate the result. That's really important for you to observe. Okay, so now I want to do a similar analysis as we did previously for the all positive problem. Okay, so question number 1. Why are we setting this particular variable over here to be false? Okay, let's try to answer in a way, rather than directly proving that false should be the case. Why don't we try the alternative? What if we set the initial value over here to be true? Okay, that's basically what we're going to do. Okay, so what I would do is I'll create a new page over here. Okay, and then I'm going to copy and paste this fragment of code, and then I'm going to show you exactly what I meant. Okay, let me just copy that. Okay, so now what I will do, first of all, so this is the fresh code over here. The only place I'm going to change will be change that from false to true. Okay, what can go wrong? Okay, and I'm also going to modify the input a little bit. Let's say I simply modify that into -4. And also I modify that into -5. So now, given this new version of NS, okay, let me just draw that quickly. So you got -2, you got -7, you got -4, you got -5, you got -1. Okay, and then I'm just going to draw the array over here properly. Okay. Okay, so what about indices? So index 0, 1, 2, 3, 4. And this is NS. Okay, let's talk about this particular array. First of all, without running the program, what should be the expected output? When we say sum positive, do we have at least one witness that is going to show it's positive? Can this be the witness? No, it's negative. Can this be the witness? No, it's negative. This cannot be the witness. This cannot be. This also cannot be. So that means the result should be simply false. But is our program going to return exactly false as expected? The answer is no. Let's see why. So now what we have is this. You can since you understood from the previous tracing, let me just go a little bit more abstractly. Okay. So now the initial value for true is for some positive is simply just true. What about for the very first iteration? For the first iteration, some positive is simply reassigned to its current value, which is initial value true for the very first iteration, or ns at position 0 larger than 0. Okay, so now to be honest with you, I don't even have to worry about what this value is. It can be either true or false, right? However, since I already got true over here, it's guaranteed the result should be, for disjunction, just true. Agree? Because remember we said as long as one of the operands for the disjunction is true, the result will just be true, no matter what the other operand is. Okay, in this case, I don't have to even care what this result is, because the left operand, which is the initial value for some positive, is already true, so the overall result will just be true. What about second iteration? The second iteration we'll try to do again, some positive is reassigned to. Now, the latest value for that will just be true, okay, or ns at position 1 larger than 0. Again, I don't have to care what this is, because the left hand side is already true. The overall result will just be true. Okay, hopefully you can see the pattern over here that's wrong, right? Let me do one more. Okay, let's say for the third iteration, we say some positive over here is reassigned to. The latest value for that is simply just true. Or ns at position 2 larger than 0. Now, I don't have to care, do I? Right? Because this operand is already true. So the result will just be true. Okay, hopefully you can see this pattern here. So that means since we talk about disjunction over here, if you want the accumulated result to be meaningful, the initial value should be true. Oh, sorry. Let me say it. Sorry to say it again. The initial value must not be true, because if you made it true, there's no way you can actually get the other result. It will just always be true no matter what. Okay, so that means setting this to be true when you have the disjunction for accumulation is simply not correct. Okay, let me remind you again, as we did previously, in the case where we try to do all positive, where the accumulation operator is simply conjunction, and we say that if you want to do conjunction here, it would be wrong if you try to use the false as the initial value. It would be wrong. You can see it's completely symmetric between the two problems over here, because once you get false over here, it doesn't really matter what the other operand is. It doesn't really matter, because it will just be false for conjunction anyway. Okay, hopefully you can see the comparison. Let me go back here. Okay, so now I just explained why the initial value for this particular Boolean variable, when we got disjunction as the accumulation operator, the initial value should be false. Okay, that's correct. And when it is true, it is not correct. Okay, so now let's analyze the second question. Okay, the second question is, what if we got an empty array? Okay, how is it going to work? So let me just paste the same fragment of code over here. Let's try to see very quickly. Okay, if it is just an empty array, and let's see over here. So now let's say we simply, rather than having this particular initializer, okay, so again, you got two ways to create an empty array. You can simply say empty brackets and semicolon. That's approach number one. Or you can say it's a reassigned to new integer array of size 0. Okay, either way works. So how does the empty array look like? So now let's see for the visualization here. So ns, rather than pointing to some non-empty array, is going to point to something like this. It's going to be ns pointing to something, some array over here. You can think about it as pointing to some memory location, but it just stored nothing. Okay, it says empty array. Okay, it's simply empty. More importantly, you should realize for empty array, ns.length will just be 0. Okay, so now let's see exactly how we can illustrate this. Okay, so we know that ns.length is simply just going to be 0 over here. So let's see how the things will work. So now let's see this. So the Boolean variable over here, some positive, we're just going to correctly initialize that to be false for the reason we just explained. So it's just going to be false over here. Okay, and then what happens when we try to evaluate this head of the loop for the first time? Initializing I to be 0, and also what's this? I is 0 less than n is the length will just be 0, which is false. That means this expression over here is false right away, immediately. That means we don't even go inside the loop to execute the body of the loop for the first time. So we completely bypass. So that means simply exit from the loop, and then here when we say, when you try to print out, for example, you try to say print line, and then you simply say sum positive, and then you simply just do the Boolean variable over here, right? So you will simply say sum positive. So in this case, it will simply just be false. Okay, so now the question is, the false over here is the return, is the result for empty array. If we go with the following logic, the initial value for the Boolean variable is simply false, and also we use disjunction over here. Well, of course, in this case, for the empty array, you don't even go into the loop to execute the first time, right? So now the question is false the correct return value? The correct result to actually to say we given an empty array. So what does false really mean? So give some elements in an empty array is positive, and then we're saying that it is not the case. So now let's consider this statement very quickly logically. Okay, we do the same analysis, we did it symmetrically before. What we did before for the all element, when we say all elements in an empty array are positive, in that case it is true. The reason that it is true intuitively, you can think about, you cannot find a violation witness. You cannot find a violation witness. You cannot find a witness that proves to you that there's at least one element that is not positive, in which case the result should be false. In which case, yeah, but now since you cannot find it, so everything is positive, so that's why it's true. Okay, so now similarly, so now if you go back to this particular illustration over here, so now how do we consider this? Some elements in an empty array is simply positive, is false, simply because you cannot find a, rather than violation witness, is called satisfaction witness. Okay, satisfaction witness. For example, if the array goes like this, if the array is simply like there's a -2, -3, and also 4. In this case, 4 can be the satisfaction witness, right? On the other hand, if you got -2, -3, and -4, in this case, this cannot be the satisfaction witness, this cannot be, and this cannot be. In this case, that should be false, of course. And of course, this should be true. Now, we use this, apply the same logic for the empty array. In the empty array, there's no elements in the array, so that you cannot find a satisfaction witness. Actually, you cannot find any witness of any kind anyway, right? Because that's empty array. Since you cannot find a witness that proves the satisfaction, so the result should be false. Okay, so now I really want you to really gain the intuition about, in the case of the empty array, for the two solutions, right? Some positive versus all positive. It's really important to realize exactly how the rationale is behind these two problems over here. Okay, let me see what else. Okay, so let me just recap very quickly. Okay, so what we have done so far, we have done two programs over here for version 1. So all positive is, let me just go back to this original slides on the iPad that I want to say. Let me just recap from there. So we are trying to solve two kinds of problem over here. The first kind, we want to see if, for both kind of problem, we want to determine either true or false. The first kind, it will be true if all the elements satisfy a particular property. For example, all the numbers are positive. For the second kind, we will return true if there's at least one. So there's some elements in the array that satisfy a property. Okay, so there's at least one number that's positive, for example. To solve these two problems over here, you really want to understand. You want to use a Boolean variable over here, and then the initial value for the two cases will be completely opposite, right? You want to know which one is which. Okay, so don't be too surprised. You might be tested later. I may not give you the correct version of the initial value being true over here. I might say I will have all positive, but I will simply initialize the value wrongly to be false. Or similarly, I might initialize some positive wrongly to true. So you want to know what the consequence is for that. We already explained the rationale if you go wrong. Okay, and also in the first problem over here, you want to use conjunction, and for the second problem, you want to use disjunction. And more importantly, you want to understand the empty array cases, right? Let me just repeat very quickly, and then we are done. Okay, in the case of the empty array for this first problem over here, the result should be true, simply because in an empty array, you just cannot find a witness that shows you that the property is violated. Okay. In the case of the empty array for the second problem over here, you will simply give false, simply because you cannot find a witness in the empty array that shows the satisfaction for the property. Okay, so now I really want to make sure you get straight for these two problems over here for version number 1, and then we'll talk about the other 3 versions in later videos.